Okay, so you should have already downloaded this document from your eClass page. If you have not already done that, then pause the video and do that before you continue so that you can take notes so you have that to follow when you're doing your work. Okay, I trust that you have it in front of you now. The first part of this says labeling your own algebra tiles. Well, we're going to use algebra tiles in order to be able to model equations. So the size of the algebra tile represents different things. The first one is just square. So we're going to call it a 1 by 1. That's our label, 1 by 1. The second one is a rectangle, and we're going to call this side x. We don't know how long it is. We're going to call it x. This side we're going to call 1. Notice that the length of this side here is the same as the length of this side here. So it makes sense that it should both be 1. Of course, every side on the square is 1. Now we go to this larger one. It's also a square, but it's much bigger than this square. So we have to give it a different name. But if we look at it, we will notice that, change colors, this side is the same length as this side. So we can label the larger square x by x. We have to have something to represent positive numbers and something to represent negative numbers, because if they look the same, then we won't be able to tell them apart. It says, what do the red tiles represent? Well, I don't have any red tiles, but let's pretend that I do. Well, here, I can make a red tile. Hold on. There, that's a red tile. So the red tiles are going to represent negatives, negative numbers. And the blue tiles, get some blue. The blue tiles, and these can also be blue, and this can also be red. So any of them can be red or blue. But the blue tiles are going to represent our positive numbers. Now you may see ones that are different colors. The ones that I have in the classroom, some of them are green and red, and some of them are pink and orange, I think. So the only thing is that you just have to choose which one's going to be negative and which one's going to be positive and be consistent with that. So zero pair examples. A zero pair is something that adds together to make 0. So if I have a negative, and we said this represents a 1 by 1. Well, 1 times 1 is still 1. So a negative here represents negative 1. The positive represents positive 1. So if I take and I add negative 1 to positive 1, I get 0. Now over here I have a positive x, because x times 1 is going to be x. So I have a positive x. I have a negative x here. So a positive and a negative that correspond, that are the same thing, same size, same shape, will equal 0. So if I had a positive large block and a negative large block and added those together, that would also give me 0. Those are called zero pairs. When we have a zero pair and we're working with algebra tiles, we can match them up and take them away because they cancel each other out. They make it zero. So here, we're going to try this out. Okay, so I have my algebra tiles, and the first one says 5x. Let's make that bigger. 5x. That smaller. Okay. So x, remember, was the rectangle, and it's positive, a positive 5. I'm looking at the number in front. This is called a coefficient. The number in front is called a coefficient. Coefficient. You'll want to remember that word. The coefficient is the number in front of a variable, and the x is called the variable. That's because we don't know what it is. It could vary. It could be one thing one time and a different thing another time. But one thing for sure, x is always x. So if this x is 3, then this x is 3, and this x is 3. If this x is 1, then this x is 1, and this x is 1. So let's get back to our algebra tiles. Put that word up there in case you didn't get it. So 5 x's, and they're positive, so I need 1, 2, 3, 4, 5. And that represents that first monomial. Okay, so a monomial. A monomial. That's an O. Has one term. Since this is by itself, we say that it has one term and it's a monomial. So we're adding a monomial to a binomial because there are two terms in the second parentheses. So this one is called a binomial, two terms. Okay, now we need to represent the second one, and we're adding them together. So if nothing's going to change over here because this is a plus sign. So I have 3x squareds. I don't know if I'll be able to fit all this on here, but I'm going to try. Because that's the big squares, remember? 3x squared plus 3x. So I need 3 more of these green ones that look like that. So 1, 2, 3. So how do you suppose I figure out what the answer is to this expression? That's right. I just count all of them that I have that are the same. So I have these 3 green ones, big green ones, that's 3x squared. And then I have 1, 2, 3, 4, 5, 6, 7, 8x plus 8x. And that is the answer. I'm not going to get just a number, because it's an expression. Can anybody tell me the difference between an expression and an equation? That's right. An expression doesn't have an equal sign. Expression. Let me change colors here. expression has no equal sign. An equation contains an equal sign. Okay. Over here, we have, look at all the terms here. And all the terms here. So there's 3 terms and 3 terms. So these are called trinomials. 3 terms. Now, I can use my algebra tiles, and I have negative x squared, 2 of those, no, 1 of those, negative x squared. Look, I'm looking at the 2, and I'm thinking I need 2 of them, but no, this is the exponent, so I don't need 2 of them. The coefficient tells me how many I need, so I need 4 positive x's, 1, 2, I'm kind of putting them off to the side here so I have enough room. 4. And then I need 7 negative 1s. 1, 2, 3, 4, 5, 6. And then get another one out of the bag. 7. Alright, we can just leave it that way. And then I have a positive x squared, so I'm going to get a green large square. And I have negative 5x, so I need 5 red rectangles. 1, 2, 3, 4, 5, and then plus 3, so I need 3 small green squares. 1, 2, 3. Now, in order to get my answer, what do I have to do? Yes, I have to match up the ones that I can. So, but when I say match up, I mean match opposite colors. Remember, we need 0 pairs. So in order to be a 0 pair, they have to be the opposite color. So this one is red and this one is green, so 0 pair. I can take them off. I have a red and a green here. Pair them up and take them off. I have a red and a green here. Pair them up and take them off. Red and green, pair. Red and green, pair. Then I have, these are going to be harder to pick up. I might need some help. Okay. I have 3 of those, and I can take 3 of those. Can I just put my 0 pairs over here and we'll know they're not there? So then I have this one, this one, this one, this one. So what is the answer to this equation? Oh, expression. You're right. I said it wrong. We have 1 negative x. So negative x. And the coefficient of 1, we don't write that down. We know that if nothing else is there, it means that it's 1. And this is negative 1, 2, 3, 4. Minus x minus 4. And that's our answer for this problem. Now, algebra tiles can be very helpful. But we probably need to know how to do it without algebra tiles as well. So let's see if we can do this same one without algebra tiles. Here's what I want to do. I want to take this first one and I'm going to rewrite it. Minus x squared plus 4x minus 7. Now always notice what's in between the parentheses, the pairs of parentheses. This is a plus. Since it's a plus, I can just add all these terms just the way they are. So what I want to do is I want to write this one below it. X squared minus 5x plus 3. Now I can just add them together. So minus x squared plus x squared is a 0 pair. Do I need to write down the 0? No, I don't. So here we're going to look at 4 and 5. Because the x is the same, we're just going to not do anything with that when we're adding and subtracting. So 4 minus 5 is minus 1, but we don't have to write the 1 because we have an x. Minus x is what we write down. Minus 7 plus 3, well, the 7 is larger, so it's going to stay negative, and we're going to subtract, and we get minus 4, same as we did before. I find this way, lining them up, easier just to keep track and make sure I have things lined up, and you'll see why that becomes important a little later. Okay, let's go down here, and let's try this one without algebra tiles. So, I'm going to write 3y minus 5. I have a plus, so I don't have to change anything here. I have 2x squared. Oh, I don't have an x squared up here. So let me write my 2x squared here. And then I'm going to write plus, that's a y and that's a y, so I can write 4y underneath here. And that's all I have. So now, just draw my line. Well, 2x squared added to nothing. That was interesting. 2x squared added to nothing is still 2x squared. 3y plus 4y, 3 plus 4 gives me plus 7y. Negative 5 added to nothing still gives me negative 5. So there's my answer to number 2. Okay, here we have only 2 monomials. I have 6xy plus 2yx. Are those like terms? They don't look the same. Some of you said yes, and some of you said no. But if we rearrange, can I multiply in a different order? Because that's what this means, is I'm multiplying. Can I multiply 2 times x times y instead of 2 times y times x? And now they look the same. So 6xy plus 2xy, add my coefficients, and I get 8xy. Okay. One more. Should we try this one with the algebra tiles? Okay. Well, I tell you what, let's do it the other way first and then do it with algebra tiles to make sure we're right. So I have minus 4x minus 6. And then this is plus, so I don't have to do anything different over here. So 7x cubed. Oh, I don't have an x cubed. Let me write that over here. Okay, plus 3x. I do have an x, so I can write it below that. Ooh, I don't have an x cubed with my algebra tiles. Okay, let's talk about that in a minute. So 7x cubed plus nothing is still 7x cubed. Then I have my coefficients minus 4 plus 3. 4 is larger. 4 minus 3 is 1, so it's minus 1. Oh, but I don't need to write the 1 because I have an x. And then negative 6 plus nothing else is still negative 6. Okay, so what about that x cubed? Can you imagine what that might look like if we had algebra tiles to represent it? We said that this one is x squared. And when we have another dimension to it, we would have to do this. We would have to make a cube, actually. So we'd have to put on all the sides and have a cube to represent that. I don't have that, so we can't do it that way. Okay, now we've learned to add, let's learn to subtract. What's different? In the middle, between the parentheses, we have a minus. So that changes everything. 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 There we go. So what I need to do is change the sign. Whatever's inside here is going to change. So I have 5x, and then I can drop the parentheses on the first one because that's not going to change. On the second one, though, I can drop it when I change the signs. So I'll say minus x squared because it's plus inside here. And this is plus 3x, so it's minus 3x. And now I can add them together. So I can do the same thing again if I want to, like I did before. I can do 3x squared and negative 3x squared. And I should have done my 5x first, shouldn't I? Okay, hold on, let me move that. Okay, I'm going to do 5x, and then I can bring down my terms. I don't have an x squared, so that's why I put it over further, because I want it to be first, because x squared is bigger than x. So I always want the bigger one to be first, not including the sign. And then I have minus 3x is what's left, and that matches up with the 5x, so I can just put that here, and I can do the same as I did before. So negative 3x added to nothing gives me negative 3x, and then I have 5 minus 3, so that will give me a positive 2x. Let's make sure we're right. Okay, so I had 2 positive x's, and then I have 3 negative x squareds, and then I have 3 negative x's. Okay, 1, 2, 3, there we go. Oh, I did the bottom one, didn't I? Okay, I have 3 negative x's. I have 5 positive x's. There we go. Good thing you caught that. Gotta keep an eye on me. Okay, so I have all these. Where are my 0 pairs? That's right, in the x's. So I have these 2 will match. These 2 will match. And these 2 will match. And then I have left negative 3x squared, 1, 2, 3, plus 2x. So we did it correctly. Okay. So let's model this one with algebra tiles. Minus x squared. That's one of these. Plus 4x. I'm trying to put them up against the frame of the iPad so that it's easier for me to pick up. Okay, 4 x's, 7 negatives. I had trouble finding those before. Let's see if I can find them. 1, 2, 3, 4, 5, 6, 7. Got it. Okay, and then I'm going to subtract. Oh, I better do something before I get my algebra tiles out. Well, no, I don't have to. Let's do this. Let's say we have a barrier. This is my parentheses in between them. Okay? We have a parentheses in between them. And I'm just going to do what's inside the parentheses here first. So, what I'm going to do is I'm going to take my positive x squared negative 5 x's and positive 3. 1, 2, 3. Okay, and now in order to be able to move this, in order to get rid of this barrier, I have to change all the colors. So I have to take this green one and swap it out for a red one. And then I have to take all of these red ones and turn them green. All of them have to turn green. And then I have to take these 3 here and turn them red. Okay, and that's not the same as 0 pairs because I'm just swapping them out. Okay, now my barrier just busted. I can get rid of it now. Okay, now there's nothing holding us up from combining. So let's see what we have. We can't take these away. They're both the same color. We can't take any of these away. They're both the same color. And we can't take any of these away because they're the same color too. So, what do we have? We have negative 2x squared. Positive 1, 2, 3, 4, 5, 6, 7, 8, 9. Positive 9x. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Plus, oh, they're red, minus 10. Okay? Not too hard. You just have to remember, they have to change color. There's a barrier in between them. They have to change color before you can combine them. Okay, let's go to this one. Negative 2x plus 5x minus 2xy squared plus 5x. What do we have that's the same? We have 5x, oops, 5x and 5x, they both have an x. But these, xy squared, they're not the same. Okay, what we need to do is take that negative and break our barrier, so we have to do negative 2xy minus 5x. xy, I missed the y. Okay, and then this one's not the same. So I'm going to actually move this over a little bit. And then I'm going to put this one down here, minus 2xy plus 5x. And the reason why I moved this other one over is because it's got that squared in it and this one does not, so it's bigger. So I have minus 2x squared y minus 2xy. And plus 5 minus 5, that's a 0 pair, so that is going to be 0. So this is my answer right here. Now the next part is for you to try on your own. Try it with algebra tiles. Yep, we can do all of them with algebra tiles. And I'll have a link for you to use some algebra tiles so that you can make sure that you've got them correct. So that's your own practice.